Good morning. After a little bit of a technical intermezzo, let's get started with database schema migrations without downtime. As Rasmus introduced me a little bit, I'm from the Netherlands. I'm a freelance consultant, dealing mostly with helping organizations and teams improve on their way to CI/CD and DevOps. So I'm helping older organizations, traditional organizations, go into the 21st century in terms of software development. In that role, in that capacity, I've been doing a few talks here and there. DevOps Days Riga last year was one of those events where I was talking about continuous delivery and specifically continuous deployment. I was talking about a client that I was working at where we switched from a release strategy that was roughly once every 4 to 6 weeks, and we got that down to 20 to 30 days, 30 deployments per day. So continuous deployment. Effectively, if something passes the tests, then we automatically promote things into production and continuously. At that company, we ended up doing over a bunch of services, about 50 deployments per day, sometimes even more, but that's an average. And we also had a system that was mostly highly available, not 5 nines, not by a long shot, but we were looking at not going down all the time, especially if we could prevent it. So going down during database migrations, for example, when you do 50 plus deployments per day, that causes downtime quite significantly and quite often during the day. So when I talk about that subject, doing a lot of deployments per day, and I don't really touch the database subject necessarily, then people after the talk approached me, how do you deal with database migrations in that situation? How you avoid downtime with database migrations? So I'll talk a little bit about a few strategies today in the next 25 minutes or so, and a few problems that you may want to avoid. So let's first do a few definitions. Let's get our terminology right. So this talk is about database schema migrations, not necessarily database migrations. So migrating a database from one vendor to another, not necessarily, even though we'll briefly touch on that. But this is about schema migration. So when we look at a schema, when we look at a database, and we're stuck. Yeah, we look at a schema. This is what people associate with a schema, right? This is your typical relational database thing going on with primary keys and foreign keys and all sorts of relationships between tables. You have column types, everything that we know, love, and hate in relational databases. So this essentially is the version, if you will, of your database, right? This is the state, the structure of your database, the type of your database. And that can be written in, well, it typically is written in straight SQL. Statement like this one, creating tables with the right structure and types and constraints and relationships. So going back to database schema migrations, the schema is not something that is locked, where it's impossible to come up with a schema that is right for the current situation and is right for the future, for the indefinite future, right? So at some point, we're going to have to change that structure. We're going to have to modify types or add tables or rename things or whatever. So typically, when you look at database schema migrations, they are also written in straight SQL statements. And when you look at schema migrations, what tools typically refer to is the up direction, which is where you add things. You basically progress into time. And you go from a version 1 of your database to a version 2 of your database, or n+1. And of course, there's also a down direction where you basically revert or roll back the change that you made to your schema. Not all tools support this though, and I'll get back to why in a little bit. But the down would then be the inversion or the reverse of what you just did, what you just added, and getting rid of that, essentially. Database schema migrations, depending on the tool, but typically they are executed as part of a transaction. So when the transaction is committed, then the schema migration, the change has been affected into your database. Not in every database. MySQL, for example, the current version is a little bit better in that, but earlier versions you would have auto commit whenever you do a DDL statement, so a create table or an alter table statement. You would have implicit commits in those transactions. Looking at a few tools that are available, and this is just a few of them, FLYWAY and Liquibase, and there are a few other tools, depending on the language you're in, the type of stack that you're working on. My go-to tool right now is FLYWAY, which is a Java tool. But that doesn't really matter because it's executable from the command line. You don't have to necessarily write or understand any Java to use it. So FLYWAY is the tool that I will be talking most about for the next 20 or so minutes. And FLYWAY basically allows you to write your database schema migrations as simple, straight SQL files, which are prefixed with some sort of version identification, usually a date and a timestamp or something, and then a description of whatever the thing is. Then we have one or more SQL statements describing what the change is, and that's it. And then to run that, we call FLYWAY migrate, or we execute FLYWAY migrate on the command line. And FLYWAY will then look into your database, determine the current version of the database schema, and then apply any of the changes that haven't been applied yet, and essentially walk that schema to the new version. How does FLYWAY determine the state of your database? Well, it adds another table to all the tables that you write, your own tables, and that's typically called the schema history table. And FLYWAY records all the schema changes, all the migrations that have been applied thus far, associated or along with a bunch of metadata, which can be interesting, like the time it was installed, how long it took, who did it, like from an audit perspective, that can be nice, what was applied, etc., etc. And basically, this table allows FLYWAY to determine the version, the current version of your database schema. So how do you deal with applications that are not using database schema migrations yet, and you want to start using them, and you already have a database that is in a certain state, that has a schema that is running? Well, FLYWAY has a way of doing that. Basically, what you need to do is create a dump of the structure of your database. So just the structure, not the data, not the filling, just the structure. If you use MySQL, you can use MySQL dump for that, but there are, depending on the database that you use, there are tools to dump that structure. And we then paste that into a file, an SQL file, which is the snapshot of the existing database schema. That's our base version, essentially. And then to FLYWAY, we say, okay, what we stored now, the file we saved now, that is our baseline. So you need to consider the database schema to be in this state. And from now on, everything we add is through FLYWAY. And we don't manually modify our database anymore. But this is the baseline. This is what is currently running, essentially. And then FLYWAY records the baseline in the schema history table, just like any other migration. But this is basically, this is where we start. So, and then we can add additional schema migration files and continue with that. The nice thing about FLYWAY is that it allows you to do repeatable migrations. So if you need to do certain operations every time you touch the database, that is possible. Myself, I've never used it yet, haven't had a need, but it can be done. Java migrations, so you can actually write Java code that is run as a callback during the execution of a migration. So if you have a migration that creates a table and then fills it with some data, for example, you can use a Java procedure or Java method to actually get that data from somewhere and pre-populate the database, for example. Or if it fails, you can write a Java callback that if your database schema migration fails for whatever reason, you can invoke PagerDuty or whatever. Now, FLYWAY has a specific way of undoing migrations, and that is to not do it. So the down direction in FLYWAY is available if you buy the FLYWAY Premium or Ultimate, whatever. It is not available in the open source version, but even though it's available in the paid version, they say it's probably best not to use it because it's difficult. Why? Well, this is the whole rollback or roll forward discussion, right? And then apply to a database. So let's say I create a table, the address table, for example, and I start populating that with data. And then at some point I find out that my database schema migration was actually incorrect. And I want to roll that back. There's a whole bunch of data in there that I'm now going to lose if I simply roll back. Other things happen to the database maybe in the time that happened. So undoing that migration may be difficult. And typically migrations are not that as easy as creating a table and then the undo would be dropping the table, right? We rename things or we alter things that undoing would be possibly even impossible. So they say undoing a migration is difficult. Now, rolling back typically is on a database is difficult because destructive changes, so deleting things, how can we restore that? Well, the only way to restore that is from a backup. But a backup is difficult on a system that is live 24/7 and accumulates data from the time that you actually created that snapshot. So then you would have to lift an individual table out of the backup, very ops intensive. Long-lived locks are an issue then, renames are an issue, and deletes are an issue. As we said before, or as I said before, implicit commits in transactions or in database schema migrations, you also need to be aware of that. And sharding, if you shard your table over multiple databases, then rolling that back becomes very difficult if you, for example, if you migrate shard by shard, and then where are you? And data that is actually inserted into a shard that has just been migrated, and you need to roll that shard back to the previous schema. I wouldn't know how to do that. So I prefer rolling forward in that case. Multiple databases, so if you use multiple vendors, multiple technologies, you use an Elasticsearch and a MySQL, for example, together to have views on the same data, rolling that back becomes even more difficult because then you're dealing with distributed transactions, potentially, which we do need, we try not to touch. So restoring from backups is then, well, also not a thing because you have progressed in terms of data from the backup. So that backup, you would have to do some manual steps to restore that. So I don't think rollbacks are possible. So what about downtime then? So if rollbacks aren't possible, can we avoid downtime in database migration? Sure. Let's first take a look at a simple deployment flow for a database schema migration in an app. So the naive way, the simple way would be, you know, let's assume we're in a Dockerized system. We build an image or we build an artifact in our build server. And once that's done, we stop a container that's running somewhere or an app that's running somewhere. We run our database schema migrations, and when they're done, we start the whole thing again, and the app is back, and we're good. We're good to go. We're down for however long it takes for those migrations to run, which can be quite long, can be quite significant, and especially if you do it at a fast pace and you do a lot of schema migrations, that becomes annoying. So if we want to avoid downtime, well, then the easy solution is not to do any schema migrations, but we're trying to go towards continuous delivery. So moving to a system where we can continuously, safely and quickly deliver value to our users, where we can either click a button and deploy to production, or we can go to continuous deployment where we have a completely automated pipeline that deploys our software to production. And if we cause downtime every time we deploy to production and we do it 50 times per day, that accumulates. So let's take a look at zero downtime deploys before we go into the database side of things. What we end up doing, or what we want to end up doing, is have a load balancer, for example, between us and the internet, between the app and the internet. And then we have an app behind the load balancer. And then we want to actually up the version of that app. We want to install a new version of the app. So we boot version 2.0 of our app. We add it to the load balancer, starts getting traffic, everything's healthy, and we yank version 1 out of the load balancer. If we do this right, nobody has noticed that we just improved, or that we updated our application, that we updated our service. But let's add a database. So if we want to avoid downtime in the database, no migrations. We're here about database schema migrations though, so let's continue with that. And what we need to look at is database state. So the database state, the state of your schema, that is the key thing to consider here. Look again, let's look again at the zero downtime situation, but now we added a database. The database is in version 1.0, just as much as the application is. So the application expects the database to be in a certain version, to be in a certain state, right? That's what we programmed it to do. And when we deployed it, we expect the app expects the database to be in that state. However, if we then apply a database schema migration and we actually bump the database version to 2.0, now things start to become interesting, because the app doesn't necessarily expect this to happen, and it may cause a breakage. It might not, but it could. If we delete or rename a table, for example, that the app version 1 is relying on, then all of a sudden we have a situation here. And then insert app version 2. Now app version 2 expects the database to be in state version 2, and this works fine. So there will be a window in time where we have two versions of our application running side by side while we are deploying, and one of them is going to crash or have a problem. So how can we deal with that? Well, the idea is that the old application should always work with the new database state. And that is the key thing to remember here. Because the old app is in production. It is running. We cannot touch that. It is immutable to all intents, right? So if we change our database, we need to make sure that the old app still works. And that also means that we can always go one diff back, that we can always go one build back, that we can always, depending on whether our rollout of the application went well, that we can always roll back to the previous commit, right? And that is what we want. The database state is always going to be compatible. How do we do that? Well, we decouple. We decouple the migration from the deployment. Typically, you see that the code to use the new migration is deployed concurrently with the migration, and then the migration is run and the code is deployed. We untangle those things. That's the idea. And we focus on non-destructive changes, always. Any change we do to the database is non-destructive until we have to clean up at some point. And that means that we retain backwards compatibility. So what can we do? We can add stuff. Adding stuff is always backwards compatible, right? Because the old app does not care about new stuff. It's not going to look for that. So adding things, adding tables, adding columns, we're fine. Creating indices, usually. Depends on the database engine, depends on the vendor, but usually. So let's dive into a little bit of an example, a practical example of how to do that. Let's assume we have a column surname, and we want to rename that to last_name. Relatively benign, but can cause serious issues in a running application, even such a benign change. So let's unwrap that. So the first thing we do is add a column with the new name. So now we have both the surname and the last_name columns. Now the last_name column is fresh and is empty, right? We add it, And the key thing to note here, it should be, if you're in MySQL or Percona land, it should be nullable, because we don't have any data in that column yet. So we cannot set a non-null constraint on that column. So that is the first thing we do. Second thing is we start writing to both the old and the new columns. So if you're looking at Java, for example, you have an entity, but this is applicable to any language. We now start writing, if we update the surname, or the last name rather, we have a fallback. So yes, we write last name, but we also write surname. So every time we write a record, we write both columns. And then if we read, we know that there's a possibility of surname being empty. So we try to look at last name, but if it's empty, we fall back to surname, because that column existed and we know it's non-null, so we get the data from there. And then we start migrating old records, because the thing to know is that if you only do this at runtime, you are going to not touch all your records, of course, right? Especially older records, you're not going to touch all of them. So you want to migrate columns or records that you're not touching. In this simple example, it could be something like this. We update the person table and set last name to surname wherever the last name wasn't set yet, wherever it's still null. And at this point, when this is done, last name has been filled, and now we can start reading from that column. So instead of actually referring to surname or falling back to surname when last name is not set, we can verify, or we know that last name is now filled. And we're done. Well, not completely. We need to still, at some point, remove the old column and the code associated with migrating those records and falling back, et cetera, et cetera. But that's a cleanup step. We can still do that. This is completely without any downtime. This can happen whenever you want with the app still running. But the key thing to note is this is in multiple steps now instead of a single thing. So it requires a little bit more of a strategy behind that. So we're good. Well, not entirely. There are a few challenges that you need to be aware of when you do this thing. Long-running migrations. If you have seriously big tables and you need to migrate old records, for example, that can take quite a while and can run for quite a while. Murphy's Law, a database migration crashes at 99%. So if you have a failure, can you restart? Can you resume? Do you have any metrics, any insight on what the migration is doing and where it is? Some migrations use a lot of memory in your database engine. Temporary tables, for example, depending on how you execute the migration. That can cause issues, and that can actually cause an already overloaded database engine to crash. And then you have a downtime in your database migration, unintended. Cleaning up, don't forget that. This is an important part of zero downtime backwards compatible database changes. Progress and logging. Where are you? How long is it taking? How long do we still need to go on this migration, on this umpteenth million record table? And don't forget non-nullable types. If you add new stuff, typically it's nullable because it's a new column, we don't have any data yet. But you need to be aware, you need to verify that once you switch to a non-nullable type, that your entire column is actually filled with data. So there may need to be a verification step depending on how sensitive or how important that data is. So a few strategies to deal with, or a few extra strategies to deal with some of those challenges. The lockless alter. Has anybody ever heard of that? Okay, so MySQL, and there are other database engines that actually lock a table whenever you do an alter, which is a problem. Because while the table is locked, it's usually then an exclusive lock. It cannot be written to, and writes will actually stack up and be delayed for as long as the migration is running, for as long as the alter is running. You can actually force MySQL to not lock the table if you are aware what you're doing. There is a whole series of disclaimers in the MySQL documentation. Do not do this, etc., etc. But if you really want, this is the syntax. So what we do is we actually force alter to use the non-lock algorithm. So basically it will alter your table. There are a few statements that will cause issues there. Please do read the documentation before you use this. But it can be a viable thing to use, especially on your cleanup step. Because remember, we added a column and then we transposed our records and then we are left with the old column, right? And we need to clean that up. If we do an alter table delete drop column, then without lockless alter, the table would again be locked just for dropping that superfluous, that extra column. But we can force MySQL to actually not have a lock. Unfortunately, I have no practical experience with Oracle, but I understood that Oracle is unable to do a lockless alter. So if you're using Oracle, you may just be out of luck in that particular case. But there are other strategies. And one of them is replication. The previous speaker mentioned this briefly in the main hall. So what we end up doing here is using replication in MySQL or in any database engine as a trick to do zero downtime migrations. The trick is we run the migration on the failover. So on whatever it's called, the slave or the replica or whatever the terminology is for that particular engine. So let's say we have in MySQL fashion, we have a master slave setup and both are in version 1 of their schema, of their database schema. Replication is there's no lag, etc. It's all healthy. So what we do now is we first forcibly decouple the slave, the failover. We stop the replication, the synchronization. And then it starts running out of sync, of course. But what we then do is actually do the alter that may cause a lock or other things. We run that on the failover, on the slave. We let that execute. And this is fine. Nobody's touching that failover. Maybe they're reading from it, but they're sure not writing from to it because the synchronization has stopped. And then once that's done, we start synchronization again. And yes, this can work. Then what we do is forcibly cause a failover. We switch the master role over to what was previously the slave. And now that becomes the master. And the slave, which now is still in version 1.0 of the database schema, starts replicating. And we essentially repeat what we just did. We stopped the synchronization or the replication. We run the alter. We bump the version, essentially, of the database. And we start the synchronization again. And we have now switched over master and slave, of course, their roles. But we have both bumped them to the new version. Now, there are a couple of issues with this. This is very ops intensive. And that can be a problem, but it can be a nice solution for very heavy changes or for database engine upgrades, which is another bonus. This works in MySQL, for example, if you have what they call row-based replication. Sorry, I should say statement-based replication and not row-based. So statement-based replication actually looks at the columns on the master and the slave, and it will basically ignore columns that are not present on the slave when it replicates. So if you have column ABC on the master and only column AB on the slave, it will actually replicate the data over, but it will only replicate A and B and it will discard C. And that's what we're banking on here. We're dropping a column and we want to replicate anyway. So that is a viable strategy for those kinds of things, especially if you cannot get around a lock on your table. Another tool that I want to briefly discuss is the Percona online schema change tool. This was written by Percona, so the folks doing a lot of consulting around databases. And basically what PT Online Schema Change does is add triggers to forward changes on tables. So what they do is they create a shadow copy of a table. So you have a table that contains, or that is in a certain state, or that contains a column that you want to drop. And what they first do is create a shadow copy, or the target table, that is in the new structure, in the intended structure, right? And then a PT online schema change adds triggers to the source table, the original table, that any update that happens on the source table is actually forwarded to the target table, to the shadow table. And then in small chunks, the tool will copy source data over to the target table. So that at some point, whenever this is all done, the target table has been populated with all the data that was inside the source table, right? And then at the end of the thing, atomically, the table will be renamed, and the app that is actually looking at the source table does not know that this rename has happened because it's transactional and the rename just has occurred. So at one moment it's looking at the source table, one moment it's looking at the target table with, for example, a column removed. That can work quite well. This can be ops intensive and IO intensive because it requires a system that you need to have PT online schema change running for as long as this takes, and it reads from the database and then writes to the database again. But it can be a viable setup and a viable system. So the way we run this is, for example, if we want to add an index that takes a long time, or we want to drop a table, this is how we execute PT online schema change from the command line. So basically what we say is, okay, we want to execute this statement, this alter table or alter statement on the target table test 1, on the database test, on localhost, and this will then run, and at the end you will still have test 1, but it will now have this statement applied to it, and the shadow copy has been effectively renamed to this one, and the source has been deleted. There are a few similar tools out there. The Large Hadron Migrator by SoundCloud. There's an online schema change tool from Facebook, and there's a Ruby thing from Twitter, and there are other tools that you can use as well, which basically do the same thing, and basically use triggers to forward any changes to your source table to the target table. So let's do a quick recap of database schema migrations without downtime. The idea here is that we do a little bit more planning, that we actually look at our changes in terms of multiple steps instead of one big step. We do multiple steps, we do multiple small steps, and we never do any breaking changes to the database until we clean up. Thank you for listening. This is my Twitter handle, where later today I'll post the slides without the purple. And that's my email address as well, and my site where I blog about continuous delivery, DevOps, and a bunch of other things. Thank you so much for listening. Are there any questions that I can answer for you right now?